Today, we're jumping right into the world of data science, and we're using Joel Grus's fantastic book, Data Science from Scratch, as our map. We're going to follow the entire journey, from a total mess of raw information all the way to a clear, useful insight.
But first, let me ask you something. Think about the apps and services you use every single day. You know, what are your dating app matches, the spam filter that keeps your inbox clean, and the movies that Netflix just knows you're gonna love? What do they all have in common? On the surface, they seem completely different, but they're all running on the same secret engine.
And yup, you guessed it, that engine is data science. It's this invisible force that's shaping so much of our digital lives, constantly turning chaotic data into really intelligent actions.
Okay, so let's really get into it. What are we actually talking about when we say data science? Is it just some buzzword for a statistician who happens to live in San Francisco?
Well, no, not really. At its heart, the idea is actually beautifully simple. Data science is just the process of pulling out meaningful insights from messy real-world data. It's basically a quest to find the signal in all the noise.
There's this famous Venn diagram that kind of breaks down the DNA of a data scientist into three key parts. First, you've got hacking skills. Now, don't think of secret agents in a movie. Think of a clever problem solver, someone who can write code and just wrestle with data until it gives up a solution. Then, of course, you need a solid foundation in math and statistics so you actually get what's going on under the hood. And finally, substantive expertise. This is a fancy way of saying you have to understand the world your data actually comes from. You know, are you looking at the stock market or human genetics? That context, it's everything. So, to even begin this quest, we first need to forge our tools. And we're going to do it the old-fashioned way, from scratch. So you might be wondering, why on earth would we build these tools by hand when there are so many powerful pre-built ones out there? Well, the author's philosophy is pretty clear. If you really want to understand how a car works, you can't just drive it. You got to get under the hood, get your hands dirty, and see how the engine actually works. Building from scratch forces you to gain a much deeper understanding.
So before you can build any of these complex models, you've got to master the fundamentals. Think of it like this. Linear algebra lets us treat our data like points in space, which is incredibly powerful. Statistics gives us the language to describe that data, to find the average customer. And probability helps us deal with uncertainty, letting us say how confident we are about a prediction.
And what language are we going to use to build all this stuff? Well, the author does not mince words here. While there's a big debate in the community, the book makes a strong case that for its simplicity, its huge ecosystem of libraries, and just how many people use it, Python is the clear winner for doing data science.
Okay, so our tools are forged, we've picked our language, now the journey really begins. And it always starts with the hunt for the raw material itself, data.
And let me tell you, the hunt for data can take you to some wild places. Sometimes you're lucky, and it's just sitting in a neat little file on your computer. But other times, you have to be a bit of a digital detective, scraping information from websites, pulling it from services like Twitter through their API, or querying these massive corporate databases.
Which brings us to one of the most important and maybe least glamorous parts of the job. Because once you find your data, you realize pretty quickly that it's a wild beast, and it needs to be tamed.
Yeah, real-world data is almost never clean. It is full of typos and missing values and just bizarre formatting. A single piece of data might look like this, where a comma inside the description completely throws off the structure. Trying to analyze this as is, it would be a total disaster. So the goal of data cleaning, or munging as it's sometimes called, is to turn that chaos into a clean, structured table, just like this one. You know, they say data scientists spend something like 80% of their time just on this step. And why is that? Because if you put garbage into your model, you're going to get garbage out. This foundational work is absolutely critical.
All right, now that our data is clean, it's structured, we can finally start asking it questions. We can basically consult the oracle and ask it to predict the future. And this is where machine learning comes into play.
Now, machine learning isn't magic. It's actually a very disciplined process. First, we choose a type of model, like a linear model or a decision tree. Then we feed our clean data into it, and the algorithm's job is to learn the best settings, the best parameters for that model to make the most accurate predictions possible.
Let's make this totally concrete. Imagine we run a social network for data scientists. We'll call it Data Sciencer. The million-dollar question for our business is, can we predict which of our users are actually going to upgrade and become paying customers?
So here's a little sample of the data we might have. For each user, we know their years of experience and whether they have a paid account or not. Now, just by looking at it, there's no obvious pattern here, right? Some experienced people pay, some don't. Same for the newbies. It's a jumble.
But when we feed this data into a machine learning model, it uncovers something really interesting. It finds a hidden pattern. It turns out users with either very little experience or a whole lot of experience are the most likely to pay. It's the folks in the middle who aren't converting. Now that is the kind of subtle insight that a human just staring at a spreadsheet could easily miss.
And that single insight right there is where the real value gets created. So what does this whole journey, from a messy file to a predictive model, actually mean in the real world?
Well, it matters because this whole process turns raw, meaningless numbers into something you can act on. That insight about paying users, now the business knows to target promotions to mid-career professionals. This is how data lets businesses make smarter decisions, how products get personalized just for you, and ultimately, how we can start to understand really complex systems in a whole new light.
So in the end, you see, data science really is a journey from the chaos of the real world to the clarity of a hidden pattern. It's about finding the story that's buried deep inside the numbers, which leads to the real question, what story is your data waiting to tell?